You know that feeling, right? When you're staring at a spreadsheet or maybe a lab result or even just a goal you've set for yourself, and you're just baffled by the numbers. We see these incredibly precise outcomes, and our first thought is always, wow, how did everything line up so perfectly?
Yeah, it's a feeling we've all had. We look at these things that seem like miraculous coincidences, and we can't help but wonder, how is that even possible? How could all these different moving parts get calibrated so perfectly to produce that one result?
So, let's call this the perfect numbers puzzle, because we get so easily seduced by the data, don't we? We see that perfect number, that perfect outcome, and we automatically assume that the number itself is the reason for the success. But what if it's not the cause at all? What if it's just a symptom of something much, much deeper? In that question right there on the screen, how was this so precisely tuned? That's the beginning of a huge cognitive trap. We immediately jump to thinking there must be some brilliant designer or some super complex calibration process tweaking all the dials. But asking that question actually sends us down a completely wrong path. This is what we're going to call the fine-tuning trap. It's this limiting mindset that just creates so much unnecessary stress and complexity. We get totally obsessed with adjusting all the little variables, trying to maintain this perfect, fragile balance, when the real answer is hiding somewhere else entirely. Okay, so look at these two ways of thinking. Over on one side, you've got the fine-tuning trap. This leads to what I call the anxiety of precision. You're desperately trying to solve everything with math, chasing this illusion of a perfect design. But then, look at the other side, the machinery solution. This isn't about anxiety, it's about structural inevitability. The solution isn't about getting the math right, it's about understanding the architecture, the real nitty-gritty mechanics of how things work. So, how do we make that leap? Well, it means we have to stop staring at the dashboard gauges and finally get the courage to look under the hood for the real engine. And that brings us to this key idea of the underlying machinery. This is the concept that really unlocks the whole puzzle. So what do we mean by machinery? It's just the hidden structure of a system. It's the rules, the physics, the constraints that automatically create the results we're seeing. A great simple example is a lever. The extra force you get from it isn't some finely tuned miracle. Nope. It is an unavoidable consequence of the lever's design. It's physics. The machinery itself dictates the outcome. And this leads us to a really critical realization, a huge aha moment. A number is never a cause. It is always just a symptom of the machinery. Think about it. The numbers we measure are just the exhaust fumes. They're the evidence that the engine is running. Once you really truly get that, your entire perspective just flips. Now, if you follow that logic, it leads you to a really powerful, honestly, a really liberating principle. In any system that's driven by pure mechanics, nothing is ever off. It can't be. Every single result is exactly what it was supposed to be, given the machinery. Just let that sink in for a second. Nothing can be off. What does that really mean? It means the whole idea of a calibration error just goes away. If you get a weird result, it doesn't mean the system is broken. It just means your understanding of the machinery is wrong or incomplete. This totally changes your job. You stop being a frantic tuner, and you become a curious investigator. This certainty, this idea that nothing can be off, is all rooted in what we call properties. Properties are just the non-negotiable facts about the parts of your system. You know, a component's mass, its shape, its density. These are things you can't just tune. They are what they are, and because they're fixed, their interactions produce results that are basically guaranteed. It's inevitable. So this new way of thinking changes our entire game plan. We start explaining results based on these inherent properties, not some imaginary tuning. We start to see that our measurements are just the voice of the machinery. It's the machine telling us how it works. It's not the machine's brain. And best of all, we realize that errors aren't actually errors. They're just the machine working perfectly based on properties we haven't figured out yet. They're clues. Okay, so this sounds good in theory, right? But how do we actually put this into practice? Well, here's a simple toolkit. Think of it as 3 interrogations you can use to bust that fine-tuning myth whenever you see it. All right, here they are. First, look at that perfect number and ask, is this number an actual target the system is trying to hit, or is it just a side effect of its design? Second, you have to identify the machinery. What are the actual parts? What are their fixed behaviors? And third, connect the dots.
How did the unchangeable properties of those parts force this result to happen?
Once you start using this little toolkit, I promise you, it'll start to change how you see everything. It is a really profound shift in perspective. You'll stop chasing your tail trying to tweak numbers, and you'll start actually understanding the fundamental structure of the systems all around you.
So if there's one thing to take away from all this, it's this. Problems that look like they need impossibly perfect fine-tuning, they aren't math errors you need to fix. They are structural mysteries you need to solve. The answer is always in finding the machinery, not redoing the math. And in the end, it all comes down to this beautifully simple truth. The machinery just does what it does. There are no miracles, there's no magic tuning. There is only the elegant, unavoidable, and predictable logic of a machine doing its thing. So I want to leave you with a question to chew on. Think about your work or your life. What seemingly complex problem have you been trying to fine-tune? And what might happen if you just stopped looking at the numbers for a minute and started searching for the engine that's been humming away underneath it all along?